Hello, I'm Dr. Sherry Hemmingson, a molecular spectroscopist and product specialist at JASCO. Thanks for taking time today to learn more about fluorescence with me, or in general, things that emit light, or luminesce. Luminescence is all around us. You might have seen it if you watch crime shows and they're looking for residual blood stains using luminol, or perhaps you're into FOLED display technology, phosphorescent light-emitting diodes for your TV, or perhaps just for fun, you played a round of glow-in-the-dark putt-putt or late-night bowling. All of these things involve species that emit light. Luminescence is cool. Bioluminescence happens as well in nature. You might have seen fireflies, or perhaps you've been fortunate to see the bioluminescent glow of the algal blooms and in the surf at night. Each of these phenomena involve a species that absorbs energy and re-emits it as light. This emission happens on a molecular level when the right amount of energy is absorbed by the luminescent species. So let's take a closer look together over the next few minutes. We'll review what luminescence, or in particular fluorescence, is, what kinds of things fluoresce or emit, how emission is measured, and hopefully give you some ideas of whether this is useful for your work. Lots of materials absorb light. Some materials actually scatter light. Much fewer substances give back off the energy that they absorb. And some materials can do all of this. These are competing processes. But for emission to occur, two steps are required. The molecule must be excited from its ground state to a higher level electronic state. And then it has to relax back down to the ground state by giving off a photon of light. There are competing processes, but when that happens, that is emission. And there are two main types of emission that are defined by how the molecule is excited. Photoluminescence, photon, is the result of a photon of light being absorbed by the molecule and emission resulting. Chemiluminescence occurs, chemical, by a chemical reaction that produces excess energy, and that energy can be used to excite the molecule. So the most common example of chemiluminescence is when you crack a glow stick. Chemicals mix, and you see that extended glow. Bioluminescence is a specific example of chemiluminescence in which a chemical reaction occurs in a living species, like a firefly or a flashlight fish or the jellyfish. So you can see in this chart of luminescence, chemiluminescence, photoluminescence, bioluminescence, they're the most common. However, there are many ways to excite molecules. Sonoluminescence, using sound, electroluminescence, using electricity, and even triboluminescence, which is not shown here, but you can look it up online to see how to do it with a wintergreen lifesaver. Thanks for joining me on this brief review of fluorescence. I hope you found it helpful. To learn more about fluorescence spectroscopy, please visit jascoinc.com/learning center